Hi everyone, and welcome to Math 8 BCPS-TV style. I'm Mr. Parker, and I'll be your host as we work through today's lesson, which is very similar to last week's lesson about how people use data to make predictions. Why scatter plots? Well, we worked with scatter plots last week, and we're going to continue that work this week. And some of the things we talked about last week were how do weather people know when it's going to snow, how do sports teams know which players to draft or to trade for, and how do you know how long it's going to take for a taxi to show up to your house or take you wherever you want to go? So today's lesson is aligned with the learning objectives for Math 8 Week 3, which is the week of April 20th. And those objectives are that students will be able to informally fit a trend line to a scatter plot and use the trend line to make predictions. And then when provided with the trend line equation, interpret the slope and y-intercept of the equation in context. Our first objective is to informally fit a trend line to a scatter plot and make predictions. So let's take a look at what that means. Here's the same set of data pictured twice. Here are two different lines drawn to represent that data. Which one do you think would help you make more accurate predictions, and why?
Here's a Desmos activity called Fit Fights. Right now we have a red line, and I can move both of those points and all these blue data points. This meter down here will tell me how good my line fits that data. Right now, not so good, down in that red zone. So let's see if we can improve that a little bit. I'm going to try and get this red point a little bit closer to some of those blue points. Ooh, that moved me into the orange. And then maybe move this red point to be closer to some of these blue points. Ooh, now I'm in the yellow. What can I do to make it even better? Well, it looks like a lot of these points are still pretty far away from the line. Let's see if I can get a little bit closer to them. Oh, I'm in the green. That's pretty awesome.
This time I don't have the meter to guide me, so let's see what we can do. I'm thinking that maybe this point right about there, this point right about there, that looks like it might be pretty good to me. Let's see how we did. Oh, right, I got some gold trophies. So what do you think it is that made that line get into the green? Let's go back to the think about it. My guess is that when you had a choice between these two trend lines, you chose the trend line on the right. They're both pretty good, but the one on the right is just a little bit better. Let's talk about why. In all of the previous examples, we created some criteria for making a trend line that has a good fit. First, let's define what a trend line actually is. A trend line is a line that is drawn that shows the general pattern for a set of data. Last week, we saw some linear and nonlinear associations, as well as some positive associations and some negative associations. This week, we're going to try and fit lines to linear associations, whether they are positive linear associations or negative linear associations. So the first thing that we decided was that it needs to be close to all of the points, as close as possible as it can be. Second, it should have roughly half of the data points above the line and roughly half of the data points below the line. It's not exact, but too many above or below is a bad sign. Finally, the points should be randomly above and below the line. There should be no pattern to whether the points are above or below. To get a good feel for what this means, let's look at one of the examples from the try it. Let's see if the trend line from the think about it hits all the marks. It's close to all the points. Roughly half are above and half are below. We can do a quick count to see how close we are. 1, 2, 3, 4, 5, 6, 7, 8, 9 above. 1, 2, 3, 4, 5, 6, 7 below. That's about half. And then are they randomly above and below? Yep. There's no pattern to discern here about how the dots are above or below the trend line. So thinking of those three requirements for a good trend line, this trend line is close to all of the points, has roughly half of the points above and half of the points below. And to illustrate that point, I'm going to go ahead and count some of these. So this point is above 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we'll check out some of the points that are below in a different color. So here I have 1, 2, 3, 4, 5, 6, 7. So 10 above the line, 10 below, or 7 below the line. That's not too bad. That's roughly half. Not too many above versus too many below. So far, so good. Looks like this might be a decent trend line, but I have a feeling that most of you picked the other trend line, and it's because of this reason, number 3, that they are not randomly or above and below the trend line. And to see what we mean there, if we look at x values that are less than 12, so these points over here, most of those points tend to be below the line, versus if we look at x values that are larger than 12, most of those points tend to be above the line. So there is a little bit of a pattern, and I can predict where our trend line is either going to be over predicting or under predicting our data. What about our Desmos activity, fit fights? Here we had this line, and we wanted to see if it is close to the points. I'd say all those points are pretty close to that trend line, roughly half above and half below. I'm just going to eyeball it this time, and I'd say that's probably accurate as well. And is there any pattern? Well, I don't see any. Maybe at the beginning they're a little bit below, but other than that, then they seem to be pretty random. I think that's why we got into the green. How about this other activity from Fit Fights where I won a trophy? I don't know if you remember that. Is it close to all the points? Pretty close. Roughly half above and half below. Again, eyeballing it, I'd say we did a pretty good job there. And randomly above and below without any pattern, I'd say that's a pretty good check mark too. I think that's why I won a trophy. This is a Desmos activity called Line of Best Fit. We are asked to draw a line through the green points that fits them best, and which purple point that line might intersect. I think my line would go right about here and intersect with purple point B. I drew a line in my head. All right. On this next screen, it says, imagine that the line the line that you drew in your head continues out to x equals 100. How high do you think the line will be at that point? Well, at this point here, which is about 15, it has a height of 5. And it's probably not going to go right through 0, 0, but I'd imagine that it's going to go up a pretty decent amount. So maybe 15 is about 1/6 of 100, so maybe 6 times higher. That's going to be my guess, so I'm going to say 30. Let's see how that goes. I watched some BCPS-TV and learned about making lines that fit the data. That's how I made my approximation there. Ooh, so now we actually get to try it. So I'm going to try and pull these points down to best represent the line that I had in my head. And the line that I had in my head, I want to make sure that it has some points above, some points below, and a random pattern of above and below. So I have above, above, below, below, above, below. I'd say that's a pretty random pattern. Goes through point B, like I said on the previous screen. I feel pretty good about that. Well, we had the 3 requirements. It's close to all the points. Oops, a little typo there. We said the second requirement was roughly half the points are above and below. Are above and below. Random pattern to above and below. All right, that's my thinking on that. Now we get a chance to calculate. So Desmos calculated the equation for my line that I drew, which is y equals 287 thousandths x plus 441 thousandths. And I'm going to use that equation to calculate how high the line will be when x equals 100. So I am going to retype what Desmos typed, except instead of x, I'm going to type in 100. And then I am going to add my 441 thousandths. Ooh, and my new estimate is 29.141 or 29 and 141 thousandths, which was pretty close to my previous estimate of 30. So I'm feeling pretty good about my skills right now. Oh, I forgot to click share with class. Let's see what happens. Oh, wow. Ooh, look at that. My estimate and my calculation were so close together. That's pretty good. I feel pretty confident. Can you try one on your own? Try to visualize a line that fits the data and use the line to make a prediction for the number of pages that would be read in 5 minutes. Was your answer between 15 and 30 pages? If so, your line was probably a pretty good fit. Well done! Now that we found a way to get lines to fit our data, it's time to start interpreting what these lines are telling us about our data. For our second objective of the week, we will interpret the slope and y-intercept of our trendline equations. In future classes, you will learn how to create these equations, but for now, they will be given to you. So let's think about it. Here is a scatter plot with a trend line drawn. What are some things you know just from looking at this graph? Here's what Kayla has to say about it.
The farther the shop, the less people visited it. More people went to the closer shops. The points are in a relatively close line. 2 points are directly on the trend line. 1 point is farther from the trend line than the rest, the point with the smallest distance.
Here are Jacqueline's thoughts. She thinks the line looks like a best fit line. She also noticed that as the distance to the coffee shop increases, the visits per week decreases. There are 14 points on the graph, but the line only intersects with 2 of those points, right here and right here. There are an equal number of points that go over and under the line, 6 of each. And after 9 blocks, people don't seem to want to go get coffee anymore. A little deeper here. Here's the graph that we were presented with for the think about that has the visits per week and the distance to a coffee shop in blocks. We have an equation for this trend line, which is y equals the opposite of x plus 9. This equation is given in slope-intercept form, which means that I can look at the equation and determine what the slope is because m is the slope and b is the y-intercept. So in this case, m is -1 and b is 9. The slope is -1, or written as a fraction, -1 over 1. One reason that we might want to look at this in a fraction is because slope is the change in y values, visits per week, versus the change in x values, which is the distance to the coffee shop. Since the slope is an integer and we want to convert it to a fraction so that we can compare the 2 units. In this case, the units would be visits per week and blocks, because those are the units that we have in the graph right here and right here. So what we need to do is think about what does the slope mean in terms of this problem. In this case, because the slope is -1 visits per week for every block, that means that for each block away a coffee shop is, it can expect 1 fewer visit per week. The y-intercept represents the initial value, or the value when x is equal to 0. In this case, the y-intercept is 9, which means that a coffee shop that is 0 blocks away, which would be right out your front door, would be visited 9 times per week. Now try one out on your own. For this graph and equation, what does the slope of -50 mean? Think about your units. Since slope is the change in y, here are my y value units, versus the change in x, and here are my x value units, or alternatively stated, rise over run, then the slope will have units that are the units of the y divided by the units of the x. So a slope of -50 means that there will be 50 less canoes rented per month, and again it's less because there is a negative sign, for every inch of rainfall. Now, -50 was not a fraction, so it can be helpful to convert it to a fraction, -50 divided by 1, where the numerator, -50, would have the units of the y value, in this case number of canoe rentals per month, and the 1 in the denominator would have the units of the x value, which is the average monthly rainfall in inches. So that's where we got that -50 as a slope in this problem means that 50 less canoes will be rented each month, that there is an extra inch of rain. What about the y-intercept? What does that mean in terms of this problem? The y-intercept is 475, which means that in this problem, our starting value, which would be for 0 inches of rain, we would be starting at 475 canoes. So in a month that has no rain, we would expect approximately 475 canoes to be rented. Let's try one more. This time you will have to determine the slope from the equation and interpret it. What is the slope and what does it mean? In this case, the slope is 8, and that is again because our equation is in slope-intercept form, or fairly close to slope-intercept form. Comparing the y value units to the x value units, that means that 8 students were enrolled every 1 year since 1997, approximately, because this is a trend line, so it's not an exact fit. And you can see from the data that there are some years where there was more than 8 and some years that there were less than 8 students enrolled, extra students enrolled. What about the y-intercept? In this case, the y-intercept is 200. That represents time 0, or where it intersects with the y-axis. 200 would be the number of students enrolled at the year 1997, since 1997 is 0 years from 1997. Now, we can look at the data and see that actually there were roughly 180 students that were enrolled that year. And that's because trend lines are just that. They show the trend, but not necessarily the precision or accuracy that the data itself shows. We're meant to use these to make predictions and help us understand the world in which we live. They're not exact models, but they can be very useful for helping make decisions about the future. Some math from my life over the last week, some fiddlehead ferns, and some spirograph art.